Hi, I'm Miss Hall, and in this lesson we're going to review how to solve one variable inequalities. It's helpful to maybe compare what an equality is versus an inequality. So an equality is two expressions that are deemed equal, that equal each other. So here's a very basic equality, which is x equals 3. That's different than an inequality, which is two expressions that are not necessarily equal to each other. And we have these four symbols we use to represent an inequality. So we have this symbol, which represents x greater than 3. And I also want to show how we represent that on a number line. I'm going to make this point 0, and then 1, 2, 3. I'm going to label that 1, 2, 3. Just want to keep a consistent scale. So to represent x greater than 3 on a number line, I put a circle above 3. I do not fill it in because x cannot be 3. And then x is greater than 3. So here are the values that x can be as represented on a number line. Let's do this again for x is greater than or equal to 3. So again, let me line up this 0, 1, 2, 3, 1, 2. And the difference here, so x is greater than or equal to, so this is when we fill in this circle, and it's still greater than values. Okay, let's do some more. X less than 3. So we start at 3. X is less than 3. So here are the values where x is less than 3. We do not fill it in because x cannot be equal to 3. And then we have x is less than or equal to 3. So that's going to look very similar to the top one, to the one previous example, except at this point x can be 3, so we're going to fill that in to show it can equal that, and it's less than. Okay, so here are the four inequalities we're dealing with. Maybe I'll just put a note up at the top, but you see it there that a filled in circle means less than, equal to, greater than, equal to, and an empty circle means less than or greater than. Let's do some examples of solving one variable inequalities. Here are the two steps that we're going to do. We are first going to find the boundary. We're going to change the inequality to an equality to find what would make it true. So in this case, we have negative 4 times x plus 3 over 5. It is a less than or equal to, but we're going to change it to figure out what x value will make it true. Okay, so this is all of step 1. We change it to an equal sign. So I'm just going to equal sign and try to color code here. Let's solve for x. To get rid of this dividing by 5, I'm going to multiply every term by 5. So I end up with negative 4x plus 3 equals 5 times 4x minus 12. And then we distribute and we get negative 4x minus 12 equals 20x minus 60. And then I will move these negative 4x's over here. So I'll have negative 12 equals 24x minus 60. I'll move the negative 60 this way. Yes, by adding 60 to both sides. So this will be 48 equals 24x. Divide both sides by 24, and I get that 2 equals x. So I have found my boundary point. Now, second, what we're going to do is we're going to check two values on either side of the boundary to determine the solution to the inequality. So I know this inequality, 1, 2, is going to have a boundary at 2. It can be equal to, so I'm going to shade this in, and then I don't know which direction it's going to go. So how I'm going to check it is I'm going to test a point to the left. So I'm going to see what happens if x equals 0. And I'm also going to test a point to the right. And here I'm going to see what happens if x equals 4. any number to the left or right works. You want to do one on each side. Only one should be true or you've done something wrong. I happen to really like 0 because it often makes it easier to simplify. So we have 0 plus 3 divided by 5 is less than 4 times 0 minus 12. Minus 12 is the left side, and this is going to be negative 12 divided by 5. Negative 12 divided by 5 is going to be some decimal value. It's going to be like negative 2 point something. I know it's not smaller than negative 12. I know that this is not true. So I don't think the arrow is going to go this way, but let me check by checking a value that's bigger than 2. So now we have negative 4 times 4 plus 3 divided by 5 is less than 4 times 4. I forgot what I was checking, minus 12. So it's going to be negative 4 times 7 over 5. And this is going to be 16 at minus 12, which is 4. I already know a negative number is going to be less than a positive number. Let's finish this out. So this is negative 28 over 5 is less than 4. This part is true. So I know that 4 is part of the solution set to this inequality, which means the arrow goes this way. And let's think back to the first side, how I would write this inequality is x is greater than or equal to 2. And that's the solution to this inequality. Okay, so we're doing the check in red. Now it is your turn to pause and try a problem, and then unpause the video when you're ready to check. We're going to begin by setting the sides equal to each other. I will distribute, get 21 minus 7x equals 14. Subtract 21 from both sides and get negative 7x equals negative 7. Divide both sides by negative 7 and get x is equal to 1. So my inequality on the number line, I know 1 is going to be a boundary point. So let me circle 1. It cannot be equal to 1 because this isn't greater than or equal to. And now let me check a number on either side. Let's check, could x be 0? And then could x be 10? So we have 7 times 3 minus 0 is greater than 14. 7 minus 3, so this is 7 times 3. Is that greater than 14? 21 is greater than 14, and this is true. So that makes me think 0 is going to be part of the solution, so it's going to go this way, but let's double check by trying a value that is greater than 1. So we have 7 times negative 7, and I can tell you that's not going to work because this is a negative 49 is not greater than 14. So this is not true. So 10 is not part of the solution set, which means the solution set is all the numbers less than 1. So x is less than 1 is the solution to this inequality.